Hi, I'm Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. And this is a good question. It's the area of an equilateral triangle. We're going to derive the formula for this area. And so we will start by drawing an equilateral triangle. I don't know if we do have triangles here. So let's see what we can do with an equilateral triangle. Make something look like it's equilateral. That looks pretty equilateral. Let's see, move it. I should be able to just move this thing, but I don't seem to be having any luck moving it. So we'll just stick with it as is. So each one of these angles is 60 degrees, and each side is congruent with the other sides. And we're going to start by dropping a perpendicular here. And now I'm just going to fill some things in here. And we'll go with, now originally these angles were 60, and of course they still are 60, these base angles. And this is a perpendicular line here. So these are 90-degree angles, and so these up here have to be 30. Now, you're supposed to know the rules for 30, 60, 90 triangles, and I'm going to put them up top here in red. So if you have a 30, 60, 90, this is A, this is 2A, this is A root 3. And if you don't have this memorized, you should have it memorized. I assume you're taking geometry, and you are going to be studying your special right triangles. You may not have encountered them yet, but I would think that you're getting close. In any event, this is the standard layout for any 30, 60, 90. Now, we're just going to say that each of these sides here, we're just going to pretend that each side here is B. The base, oops. The base was B. Now, because these two triangles are congruent with each other, they're both 30, 60, 90, and they share a common height, which we'll call H. So you can see angle side angle here would work if you wanted to prove, or hypotenuse leg would work if you wanted to prove that these two triangles are congruent. And so each one of these is B over 2 here. Okay, so now we have everything we need except an expression for the height. Now, see up here we have H is equal to A root 3. And A in our example is B over 2. You see that? It's opposite the 30. It's opposite the 60. Here's the height opposite the 60. And you can see opposite the 60 is A root 3. And A in our particular case is B over 2. So we have B over 2 root 3. And so now we're ready to derive the formula. And We know that the area of any triangle is 1/2 base times height. So in this particular case, it's going to be 1/2. Now the base is still b, but we just need this expression for the height. So it's times b over 2 root 3. And we can just clean this up. So this would be root 3 over 4 b squared. And there it is. That's your, we've just derived the formula for the area of an equilateral triangle. And hopefully you'll find that to be a shortcut. If you memorize the formula, you can use it every now and then when you need the area of an equilateral triangle. It comes in handy, but if you can't remember the formula, all you really need to do is remember how we derive it. Okay, so that's it for this problem. I'll see you again next time. Bye-bye.